All right, hi folks. This is Larry Mussolino. I wanted to record a short video to help you get started in the Module 1 homework in MyLabs for Math241. A few students were asking me about some of these questions, so I thought it'd be good to have a video to summarize. So let me do a few examples. There's going to be a few questions that ask you to come up with a formula for a graph. And so to analyze this, we have to first notice that we're going to need what's called a piecewise function. What that means is there's really two distinct parts to this graph. I'll call it the left side and the right side of this graph. So the way you denote this is you give a piecewise function where you specify the equation for the left side of the graph and you specify a different equation for the right side. And notice it says here x less than or equal to 1. So here's 1 on the x-axis. So that's describing the left side of the graph. And then it says x greater than 1 is a different equation for the graph. So what we really have to do is come up with an equation for the left side, an equation for the right side, and notice that this transition happens at x equal 1. The other thing to notice is this is a filled-in circle. And over here is an empty circle. Now, what that's telling you is the filled-in circle is telling you that x equals 1 is part of that graph. So the endpoint is included as part of the graph. The empty circle tells you x equal 1 is not part of the graph. This graph starts at greater than x equal 1. So this graph is going to really start x greater than 1. And this left side is going to be x less than or equal to 1. All right. So let's try to analyze the left side and the right side. Well, the first thing I'm noticing is the left side is a downhill curve. Well, this has to have a negative slope, right? A downhill line is a negative slope. An uphill line is a positive slope. And so you probably remember that the equation of a straight line is y equal mx plus b. This m is the slope. So what I'm noticing here is the left side graph must have a negative slope, a negative m. The right side graph has to have a positive slope. Well, I can rule out some of the answer choices based on this. So the left side graph has to have a negative slope. Well, if you notice here, this slope is positive, so this answer is out. This slope is positive, this answer is out. Both of these answer choices, A and B, have a negative 2x for the left side of the graph. So what I have to focus on then is the right side of the graph. Is the right side of the graph, does the equation match up to x plus 2 or x plus 1? Well, without doing too much work, I can see it's going to be x plus 1. How do I know that? Well, if you look at this graph closely, the b value is the y-intercept of the graph. That's where the graph crosses the x-axis. But I could see this graph here doesn't cross at x equal 2. It crosses at x equal 1 if I was to extend it back. Now, I know it really doesn't extend back, but I can visualize it just to determine the y-intercept. So I know the answer can't be x plus 2 because that line is not going to go through the y-axis at 2. It's going to go through the y-axis at 1. So a little bit by process of elimination, I can figure out the answer here has to be answer B for this choice. So again, this is a piecewise function. You can analyze the left side graph and the right side graph separately, and that should help you figure out the correct choice on that one. Let's do another example. All right, here, this one's a little more difficult because for this one, they're asking you to write the equation of the line. And so let me show you the solution so then we could talk about it. It'll make things a little easier if I show you the solutions. All right, and so let's focus on graph A for a second. Well, I'm noticing there's two parts to this graph. Again, this is, you can think of this like a piecewise function. So think of this as the left side, and this is the right side graph. And there's a transition here at x equal 1. All right, now let's focus on the left side graph for a second. Well, for the left side graph, I'm going to write the equation of a line using a format y minus y1 equals m x minus x1. Because I can use this point 1, 1, and I can use this point 0, 0. So for this graph, there's 2 points for the left side. So again, I'm focusing on the left side of the graph right now. Well, the 2 points are 0, 0, and 1, 1. When you want to write the equation of a line, we're going to need the x1, y1 values, and we're going to need the slope as well. Well, let me label these points. I'll call this x1, y1, x2, y2. Well, you remember the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, let me just plug in. The y2 is a 1. The y1 is a 0, so it's going to be 1 minus 0 on top. On the bottom, x sub 2 is 1, x sub 1 is 0. Again, 1 minus 0 on the bottom. So this is 1 over 1, which is 1. So we're figuring out that our slope here is a 1. All right, let me plug in x1 and y1. Well, our y1 value is a 0, and our x1 value is a 0. So this is going to be y equals 1 times x, or just y equals x. So that's the equation I'm going to write on the top, y equal x. Now, what are the bounds for x for this left side graph? Well, x is going from 0 to 1. Now, what MyLab wants you to do is take that value x equal 1 and associate it with either the left side or the right side graph. That's up to you. In this example, they're making x equal 1 be part of this left side graph. So notice it says x less than or equal to 1 there. All right, so we took care of the left side. Now we got to figure out the right side of the graph. Well, if I look at this right side, I'm going to use these points. Let me erase some of this to make it a little easier to see what's going on here. Let me focus now on the right side of this graph. Well, for that, I'm going to use these points, 1, 1, and this point here is 2, 0. So let's do the same kind of analysis. We have 1, 1, and 2, 0. I'm going to label these as x1, y1, x2, y2. Let me go back to the formula, y minus y1 equals m, x minus x1. By the way, this formula is called the point slope equation. I'm sure you remember this from algebra. Let's go plug in. First, we need the slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is going to be 0, subtract 1 on top. And on the bottom, it looks like we have a 2, subtract 1. All right, so that is negative 1 over 1, negative 1. So this slope is negative 1. All right, let me plug in. Our y1 value is a 1 here. Our x1 is a 1 also. So we have y subtract 1 equals negative 1, x minus 1. Let me multiply this negative 1 inside the parenthesis. Y minus 1 equals negative x plus 1. Add 1 to both sides. I want to get y by itself here. I have y equals negative x plus 2. So that's the equation I want to use for the right-hand side. What are the bounds on x? Well, x is going to start at 1 and end here at 2. Now, I'm not including 1 in this right-hand graph because I already included the value x equal 1 in the left side. And so again, you can either include 1 in the left side graph or the right side graph. It's up to you. All right, let's go to graph B. I think this one's going to be a little easier because these graphs are straight lines. Let me scroll down here a little bit. All right, let me look at graph B. And again, let me think of this as the left side and the right side. Okay, and I want to specify the left side. Well, it looks like it's a little hard to see on this graph, but this, let me label this graph, the y-axis here, make it a little easier to see. Here's y0, here's y negative 1, here's y negative 2, here's y negative 3. So it looks like this line is going to be y equal -2. There it is. What are the bounds for that? Well, the left endpoint is at x equal -1. The right endpoint is at x equal +1. So that's the left side. Let me go over, and so here is the bounds for the left side. All right, let's go look at the right side of the graph. Well, the right side of the graph is going to be this portion. Well, that's a horizontal line at y equal -3, so that's the equation there. What are the bounds? Well, the bounds are going from 1 to 3, right? X equal 1 to x equal 3. But notice the x equal 1 is an empty circle. So that means it doesn't include, that graph doesn't include x equal 1 itself. And so here are the bounds for the right side of the graph. Okay, so this is a little tricky to figure out the notation that MyLab wants here. By the way, folks, please remember you have these help buttons. View an example. We'll show you a similar example. Help me solve this. We'll help you solve this exact problem. So please use those buttons. And if you click here on more help, you could do video. That will bring up a short video. You can also use Ask My Instructor. That'll send me a message. All right, let's take a look at a couple more examples here. So here's a question that says, find the average rate of change. Well, average rate of change really means a slope calculation for a straight line. So we want to know the slope of a straight line. Well, it's going to be a straight line joining these 2 points. And without really graphing this, I'm just going to make a graph that goes something like that, let's say. And so what they're asking me is to go from x values of 3 to 5. So let's say here's x equal 3, and let's say here's x equal 5. So if I draw these points on the graph corresponding to x equal 3, x equal 5, what they're asking me to do here is find the slope of this line, the straight line connecting the 2 points. So what we need to answer this question is we need the x1, y1 for this point, and we need the x2, y2 for that point. Well, let's figure it out. Let's do x1, y1, and then we'll figure out x2, y2. We know the x values, those were given to us, 3 and 5. But we got to figure out the y value. Well, when you have f of x really is synonymous with the y value. So I can write really this equation. I'm going to replace f of x with y. So I can write this equation as y equals 2x to the third plus 2. All right, well, let's figure it out. Let's let x equal 3 for that first point. So the y value is going to be 2 times 3 to the third plus 2. That's 2 times 27 plus 2. That's 54 plus 2. I think that works out to be 56. So we just found out y1 is 56. Let me put a y sub 1 here to make that clear. All right, let's do the same calculation for the x2 value. So now we're going to let x2 equal to 5. So let's go plug that in. Y sub 2 is going to be 2 times 5 to the third plus 2. 5 to the third is 125, I think. So that's 250 plus 2. That's 252. So we're figuring out the y sub 2 here is 252. Well, remember, we want to know the slope of this line. So now we can go to the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'll plug in here. 252 minus 56 over 5 minus 3. And let's see here. What is this going to be? 196 over 2, I think. So it works out to be 98. So we're finding out that the slope of this blue line is 98. Okay, so when you see average rate of change mentioned, it's really asking you for the slope of the straight line joining the 2 points. Later, we're going to be talking about some calculus discussions and finding instantaneous rate of change. That's a different story, but this is average rate of change for this example. All right, let's do a couple more here. Let's take a look at this one. So again, this one is an average rate of change. Now they're helping you out here because they're showing you the formula for slope. You know, I can really, instead of writing it this way, I can think of it as the slope is r sub 2 minus r sub 1 over theta sub 2 minus theta sub 1. Well, they just wrote it using this alternate notation of delta r over delta theta. This delta really means change. So they're really writing it as the change in r over the change in theta. But I think it's easier to think of it as r sub 2 minus r sub 1 over theta 2 minus theta 1. All right, so let's write 2 points. Then we need theta sub 1, r sub 1, and we need theta sub 2, r sub 2. Well, they're giving us the theta sub 1 values, 1 and 5. So 1 is theta sub 1, 5 is theta sub 2. Now we need the r values. Well, let's go ahead and use r of theta equals the square root of 3 theta plus 1. But now let's let theta equal 1 for that first point. So r sub 1 is the square root of 3 times 1 plus 1. That's the square root of 3 plus 1. That's the square root of 4. That's a 2. So we're finding r sub 1 is a 2. All right, let's do it now for the theta sub 2 value of 5. So r sub 2 is the square root of 3 times 5 plus 1. That's the square root of 15 plus 1, square root of 16. So that's a 4. So r sub 2 is a 4. All right, I'm ready to plug into the slope formula. We need r sub 2 minus r sub 1. That's going to be 4 subtract 2 over theta sub 2 minus theta sub 1. That's 5 subtract 1. So that's a 2 over 4. I'm getting the answer 1/2 then for the slope. So the average rate of change here is 1/2. By the way, notice they say simplify your answer. That means simplify fractions. So be sure that you simplify fractions here as needed. All right, let's do 1 or 2 more. How about, let's see what else we have here. Okay, here's the same kind of question. It says, estimate the average rate of change from 1991 to 1993. So remember, when they ask you about this, they're really asking you for the slope of the straight line connecting these 2 points. Here's 1991. Here's 1990. Oops, I'm sorry. I messed up here. Let me erase this. Here is 1991, and here is 1993. So they're asking me to find the slope of this red line. Now notice I don't have to come up with the exact answer because it's an approximate kind of answer. So let me just try to label these points. It looks like in 1991, the number of deaths is 1,700. And in 1993, I'm going to use 1620 as my estimate. It's hard to read exactly from the graph, but remember, we don't need an exact answer here. Well, let me think of this as x1, y1, x2, y2. And let's plug into the slope formula. By the way, I can see this has to be a negative slope because there's a downhill line. So let me plug in. Our y sub 2 is 1620 minus y sub 1, which is 1700, over 1993 minus 1991. So it looks like this is negative 80 on top over 2 on the bottom, so negative 40. Well, the closest answer is negative 45, right? So remember they said estimate the average here. So again, this is finding a slope calculation of the straight line connecting the 2 points on the graph that were specified to. All right, let me do one that's a little different. Let me come here to number 13. All right, now these examples here are a little tricky, but let's do a few of these examples and see what they're asking. It says use an approximation method to estimate the area under the graph between x equals 0 and x equals 6 using two rectangles of equal width. And notice it says lower sum. So we have to understand, what do they mean by lower sum versus upper sum? All right, let's do part one, I guess, to start with. So we need a lower sum with two rectangles. Now, I think it's very, very helpful to draw a diagram. If you don't draw a diagram, it's going to be hard to visualize. So let me draw a diagram here. I know the x squared kind of graph is a parabola that looks like this. So I'm going to draw a parabola that does something like this. All right, that's a terrible parabola, but let me redraw that. That was bad. Do something like this. Okay, we want to go from x equals 0 to x equal 8. Now, what they're telling me is divide this up into two rectangles. What we're really trying to do here is we're trying to estimate this area beneath the graph and above the x-axis. So we want to estimate this blue area. What they're telling me to do is to divide this up into two rectangles. So I'm going to divide it up into two rectangles. Let me call this rectangle A and B. Now, when they say lower sum, what they mean is use the left side of the rectangle to determine the height. So let me come here to rectangle B. I'm going to use the left side here to determine the height. So rectangle B is going to be estimated by this blue area. Rectangle A, actually the height is going to be 0 because I'm using the left side of the rectangle to dictate the height. All right, let me find our area, which is really adding up the area of the two rectangles. So I'm going to add the area for rectangle A plus the area of rectangle B. Well, and what about the width of these rectangles? Well, if this whole interval is 8, and I'm dividing the interval up into two pieces, each rectangle is width 4. But area A is going to be 4 times 0 because the height is 0. What about area B? The width is 4, but we need to know the height. Well, the height is dictated by this xy point here. But I know the x is 4. I need to figure out the y value. Well, I could do that. I could figure out the y value because they gave me the function that says y equals 8x squared. So if x is 4, it's going to be 8 times 4 squared. That's 8 times 16. That is 128, I think. So the height, excuse me, the height of rectangle B we're finding out is 128. So here's the height. So again, what I'm doing for these rectangles is I'm multiplying the area of a rectangle is width times height. That's how I'm setting this up. All right, well, this is going to be 0 plus 216. Hold on a second. Let me double check something here. I just noticed I made an error here. I misread this problem. It says 0 to 6 is the are the x values here. I put x equal 8, so that was my mistake. Let me redo this. Let me erase some of this. I apologize for that. Let me get rid of all this stuff. So my diagram is still okay, except I have to make this value here x equals 6. That means each rectangle is going to have a width of 3. So let me get rid of this. All right, so area A still has a height of 0. So for area A, that's going to be 3 times 0. Again, that's width times height. Let me go to area B then. Well, we need the height of this rectangle here, and we use the left endpoint to dictate the height. That's what they mean when they say lower sum. It really means use the left endpoint. All right, well, let's go ahead and plug in here. And the reason they say lower sum is this result that we're going to get is going to be an underestimate of the true area. So let's go ahead. F of x is 8x squared. Think of this as the y value that we're going to calculate. But we're going to use x equal 3 to determine the height. So it's 8 times 3 squared. That is 8 times 9. That's 72. So the height of this rectangle is 72. All right, and so now we have the width for area B is 3. The height is 72. So I'm going to end up with 3 times 0 plus 216, 216. So our estimate for the area under this curve is 216. Well, this is a lower estimate, right? Because I could see if I highlight in green, I didn't count this area in my estimate, which I should have. And so my estimate here is not that good, because the green area is the true, it includes the true area under the curve, but I'm not taking that into account. And so that's why more rectangles would be better. So if you use more rectangles, you'll get a more accurate estimate of the area under the curve. All right, let's do the last part of this to kind of show that. Let's do an upper sum with 4 rectangles. All right, so let me draw my diagram here. Here is a rough sketch of the curve. We're going from x equals 0 to x equals 6. All right, and I need to create 4 rectangles. All right, of equal width, it says. So let me draw 4 rectangles here. I'll draw 4 rectangles like this. All right, I'm going to call this rectangle A, B, C, D. Now they're telling me use the upper sum. Well, what that's really saying to me is use the right endpoints. So for rectangle A, I'm going to use this height. Rectangle B, I'm going to use this height. Rectangle C is going to get that height, and rectangle D is going to get this height. All right, so for our area, we're going to need the area of rectangle A plus the area of rectangle B plus the area of rectangle C plus the area of rectangle D. All right, and how wide is each one of these rectangles? Well, the total distance is 6, but there's 4 rectangles of equal width, so each rectangle is going to be 1.5. So let me put 1.5 there. Here's a 3. Here's a 4.5. And of course, this is 6. All right. So I know the width of each rectangle is 1.5. I'm going to put that in here. So 1.5 plus 1.5 plus 1.5 plus 1.5. All I have to do now is find the height. Well, I know y equals 8x squared. So if I go to this point, the x value is 1.5. I need to figure out the y value. Well, I'm going to work out y equals 8 times 1.5 squared then. I'm going to do that on a calculator. And I'm getting the answer 18. So the height of this rectangle is 18. So I'm going to put that in here. Let me go to rectangle B. Well, the right side here has an x value of 3. So I need to figure out 3 question mark. All right, well, for that, y equals, so this was the calculation for rectangle A. Let me do rectangle B. Y equals 8x squared, but now we're using x equal 3. So that's going to be 8 times 3 squared. That's 8 times 9. That's 72. So the height of this rectangle is 72. And I'm going to do the same thing for each one of these other rectangles. I'll just do it on my calculator. For rectangle C, I'm using this endpoint, which is 4.5. And so for rectangle C, I'm going to work out 8 times 4.5 squared. That's 162. And for the third rectangle, x is 6. So 8 times 6 squared The height of this is 288. All right, and to make things a little easier here, I can actually factor out a 1.5 in front, make that the calculation a little easier. 162 plus 288. And if I work this out, I should end up with the answer 810. Now notice 810 would be this area of these four rectangles, but that's greater than the true area under the green curve. So this is an overestimate. And you'll notice the more rectangles, the better. Because the more rectangles, the more the area determined by the rectangles will conform to the actual area under the curve. Okay, so this one is a little calculation intensive, but drawing a diagram, I think, is an important part of this type of analysis. All right, hope this is helpful as you're working in the Module 1 homework. Please let me know if you have any questions.